All right, as promised, here's my quick review of Unit 3. We're just going to go over the problems from the practice test and hopefully get you guys ready for your test a few days later than I intended to, but, you know, weekends are weekends. So, first off, just a heads up on this test, you'll be allowed a 3x5 note card. If you do want to use one side of an 8.5 by 11 sheet of notes, you can do so, but you have to use 10 stamps for that. So heads up on that one as well. All right, the first skill that we worked with was, the very first one in Unit 3 that we worked with was laws of exponents, but that was more to have some background information on that. The next one was writing an exponential equation. So let's scoot this over just a little bit and write down some of the stuff we know about exponential equations. So first off, y equals ab to the x. In an exponential equation, as x increases, something is being multiplied by y over and over again. Whereas linear, we're adding the same amount every single time. With an exponential, we're multiplying by that same amount every single time. So there's a couple ways to go about this one. I'm going to just do the way that will work with every single one. Real quickly, to get your multiplier, you can divide 21.296 by 19.36. I'm going to show you the method, though, that'll work no matter how far apart these two values might be, and how far they are from your x equals 0. That's for the highly proficient skill, but there's several ways to go about this. So basically what I can do, I have an x here, and I have a y here, and I have an x here, and I have a y here. So what I'm going to do is set up a system of equations. And I'm going to put my bigger exponent on the top. So I'm going to plug in the 21.296 for y equals a, b, I don't know either of those, the multiplier or the starting value, to the x. And then I'm going to divide that by 19.36 equals ab to the second. So basically what I did here was I took this y, plugged it in for y, and that x, and plugged it in for x. Took that y, plugged it in, and that x, plugged it in. So I forgot to finish my thought over here. A is our starting value. It's our y-intercept. It's where x equals 0. So that is that value right there that we don't know yet. B is our multiplier. And I'm going to show you how to get that right now. So when I take these two and divide those two equations, this is why we needed the laws of exponents, I take the b to the third over b to the second, which gives me b to the first, or just b. And then I'm going to take a calculator and divide 21.296 and divide it by 19.36, and I get 1.1. In this case, that's just our multiplier. If our values were a little bit further apart, I would need to take some kind of root. Like if they were 4 apart, I would take a 4th root. But in this case, this just gives me my multiplier. So what that means is that as I go from here to here, or from here to here, or from here to here, I'm multiplying by 1.1 every time. Which means if I want to go backwards, all I have to do is divide 19.36 by 1.1. And whatever I get there, divide that by 1.1, and that would give me my starting value. However, if I'm looking at this from the perspective of these being further apart, which they're not, but if they were, I go back to that y equals ab to the x. Now, I know what b is now. B is now 1.1, and I'm going to run out of room here. And I also can look at this in terms of having an x and a y value. So I'm going to take 2 and plug it in for x, and I'm going to take 19.36 and plug it in for y. I could also use the other, wow, I just keep running out of room. So then I just need to simplify and solve. So 1.1 to the second is 1.21. So this is a times 1.21. Don't forget, a times 1.21 is the same as 1.21a. For some reason, when you put the decimal or the number in front of the variable, it throws people, but we're just multiplying here. Then I have 19.36 on the other side. And I divide 1.21. So 19.36 divided by 1.21 gives me 16. So that gives me my starting value. Multiply that by 1.1 to get 17.6 for that middle one. So now I have a starting value, I have a multiplier, then I have my equation. So my equation here, y equals, or f of x equals, depending on how you want to write it, 16 times 1.1 to the x. And that's my exponential equation for this table. All right, now I want to be able to use those equations, the y equals ab to the x, to solve in some more real-life situations. And of all the things that I teach you in Algebra 3-4, being able to do this is kind of important in life in terms of credit cards and loans and so on and so forth, and making sure that you have an idea of how interest works. Now, we don't get to get into that very much, unfortunately, but it is a starting point for you at least. So if Jack deposits $12,000 into an account, I'm going to use a different color. That is my starting value. And if he's losing 1% per month, then I need to figure out what my multiplier is going to be. And one of the things we took notes on, and you can go back to this, go back to the video on 3.2. If I have exponential decay, I take the 100% that I start with and I subtract the 1% that I'm losing to get 99%. And then I need to turn that into a decimal. 99 divided by 100 gives me 0.99. So that's my multiplier. If this were growth, I would be adding that percent, so 100% plus whatever it was, to get my multiplier. But since I am losing money here, then, whoops, sorry, wrong function. Since I'm losing money, this is decay, so that's my multiplier. And then all I have to do is plug everything in that I know. So I have y equals 12,000 for my starting value, times my multiplier of 0.99 to the x. And one of the things we talked about in the 3.2 video, I can't remember which video went terribly wrong, but one of the things we talked about was that the exponent, our x value, is really frequently a period of time. It's some kind of unit of time, whether it's weeks or months, a number of times some things happened. But that's where that's going to go. And then y is going to be my total amount. So x, I'm replacing with the 18. And then I just need to plug it in. So 12,000 times 0.99 to the power of 18. And I get $10,014.17. And because this is a story problem, I want to make sure that's got a dollar sign on it. And that's it for that one. Highly proficient, you'd be expected to find out that equation from two separate things separated by time, I should say. It's not very descriptive, but look at the back, look at the highly proficient on your worksheet from this one to figure that part out. All right. The next thing we learned in 3.3 was how to go from log form, log base b of a, of y equals x, can be rewritten in the exponential form of b to the power of x equals y. Now, what letters don't matter quite so much as where you put them. So if I've got the b here, it needs to be the b here. If I've got the y here, it needs to be over here. And if I have My x here, it needs to be the exponent up here. So it's more the placement than the actual letters. I've written it several different ways with different variables that the end result is the same. They just need to be in the right place. So this is 4, didn't mean to be in that function. There we go. 4 to the power of 3 equals x. So 4 to the third equals x. Highly proficient, you need to be able to solve all of these. 4 to the third power is 64. In that case, you don't really need to solve anything. The next one, x to the third power equals 200. You would need to be able to use a cube root in order to solve that one. And the last one, 6 to the x equals 10. And you need to use a log to solve that one. So highly proficient, you need to be able to solve it, but for proficiency level, literally all you have to do there. All right, the last one, using logs to solve. First step we have here is to isolate. So we need to isolate this 4 to the power of x. So I'm going to subtract 20. And we're isolating in the same way that we have every other thing. We get rid of addition, subtraction, we get rid of multiplication, we get rid of roots, so on and so forth. But our point here is to isolate that 4 to the x. So this is negative 96. I'm going to divide by negative 3. We get 32, so 4 to the x equals 32. And then I need to rewrite with the log form that we just did on the last one. So log base b of y equals x is the same as b to the power of x equals y. And yes, I do those every time, those little arrows. So this is going to be log base 4 of 32 equals x. And then I always go back and double check, do I have that as 4 to the x equals, oops, I suppose it would help if I wrote the right number in the right color, 32. And that's the position I'm supposed to have it in. Now, that is our first rewrite. We're going to rewrite again using the change of base form. And I didn't thoroughly explain this in the video. The common log has a base of 10, and when you put log in the calculator, it's a base 10. So we need to rewrite this. Some calculators have, you can change the base, but if you have log base b of a, that is the same as log 10 of a over log 10 of b. So when you put that in, you're really just rewriting it. So this becomes log of 32 over log of 4. And then your last step is literally just put that in the calculator. So log 32, I need to be sure, because when you put it in the calculator, parentheses automatically pops up. Make sure you close that parentheses and then divide by log 4. And I get x equals 2.5. So that is solving using logs. And that's, my dear students, is it for chapter 3. It's a pretty short chapter. So hopefully you do well on that test and make sure you get that note card ready. Have a good one.